Hi, amazing people. What we're doing today is we're looking at cumulative distribution functions. Now, these are when you need to find the area underneath the probability density function. And so what they're useful for is making it quicker to be able to find these values when you have lots of them to find, rather than do continual integrations, which are effectively the same thing over and over and over again. Now, you can see with this continuous distribution function here, what we want to do is we want to be able to find the area underneath it. Now, we might actually want to find a couple. So say we want to find, for example, we would like to find P of X up to A, but then we'd also like to find P of X up to B. Now you can see in both of these graphs, the area we're trying to find underneath the curve here is two very different points. But rather than do an integration for px less than a and then px less than b, what we can do is we can do that integration first and then make that substitution in. The reason being is they both have a commonality in this point down here is the same in both of these graphs. And so because of that, we can find then a formula, an equation for the area under a curve from this point here up to point A or up to point B. And that's what we're seeking to do with the cumulative distribution function. We have this example here where we're told that a continuous probability function is given by f of x is equal to 4x cubed over 255. Now, what we want to do here is we first of all want to be able to find a cumulative distribution function. Now, in doing this, what we're going to seek to do is in using our domain here, which is 1 and 4, we want to focus on this first point because this is going to be the starting point of this graph. And we're going to use that as one of the points. Then a second alternative point, what we're going to do is rather than use the number 4, which is what we have in the domain, we're going to use a letter to define whatever it is we need to find a little bit later. So instead of the number 4, what we're going to do instead is we're going to use x to replace that here, because x can be all sorts of different variables, as you'll see shortly. So in doing this, what we need to do is we want to be able to find capital F of x. Now, this capital F of x is a way to define the cumulative distribution function. So what we're going to do is we're going to find this, which is the integral, and we're doing it between 1 and x, those values, and it's going to be for 4x cubed over 255 dx. Now, what I want to do is I want to be able to remove the fractional part of this here, just to make it a little bit easier to undertake this integration. So it's just going to be 4x cubed now dx, which I need to integrate. So this is going to give me 1 over 255. I'm going to open my brackets up here. 4x cubed, when it integrates, becomes x to the power of 4. And again, I'm doing that between x and 1. And now I can start to make a substitution in here. So that's going to be 1 over 255. I'm going to maintain my brackets. Now, the first substitution I need to make is just x to the 4, so that's not really a change. But then I also have minus, because we've got the two boundaries here. And so the second boundary we need to subtract, and that's going to be 1 to the power of 4, which is just 1. And I would leave it like that. So what we've got here, this is the CDF, which I've just found. So now what we're going to do is we can use the CDF to find the area under the curve for both of these values here. So the first one is we want to find from the starting point of the continuous distribution function up to number 3, and then we can also do it in the second part of this, which is up to 1.6. So what we're going to do is we're going to use the CDF, which we've got up the top here. And as we do this now, what we're finding is effectively capital F and 3, because that's the substitution we're doing in here. So that's going to be equal to 255 brackets 3 to the power of 4 minus 1. And I can close the brackets. This next part is 1 over 255. That's going to give me 81 minus 1, which simplifies further to give me 80 once I multiply that in. And the 81 minus 1, it becomes that 80, and that's going to be over 255. This does simplify to give me 16 over 51, or I could put this as a decimal, it'd be 0.3137. But given this is a rounded number here, the ideal answer would be this first one here, 16 over 51. Now in the second one here, we're doing the same process again. So I'm going to have f of 1.6. So this is going to look very similar to what I just did. So I'm going to have 1 over 255, and I'm going to have 1.6 to the power of 4 minus 1. Now, as I work this out, this one's a bit more complex, so I'll type this into my calculator. I would get an answer of 0 0.0218, and this here is the answer to that. So you can see how the CDF has made it a little bit simpler to be able to work out these values here.